This short talk is actually about your brain. It weighs 1.5 kilograms, it's got 150 billion nerve cells, and they make on average 1,000 connections each. That means in your brain, watching this, there are trillions of connections. What I want to do is look specifically at the part of your brain which deals with your emotional life, what we call the limbic brain or the social cognition system. So let's look at a cutaway of the brain which specifically shows us this system called the limbic system. What I want to do first is work our way through all the various structures in the limbic system so you have an understanding, I hope, of how complex this network is. The first structure I want to look at is called the amygdala. The amygdala is your basic survival structure. It's there to keep you alive and functioning irrespective of anybody or anything else. It's very much in the present. Your right amygdala is constantly surveying the environment for threat or reward. If it sees threat or reward, it has 3 responses. Hit it, take it, run from it. It's an ancient structure. It has no concept of consequence. It doesn't know anything about the past or the future. It has no morality. It has no ethics. Its job is to keep you surviving and happening irrespective of anything or anybody else. Slightly higher up the food chain are a set of structures called a septate nucleus. Septate nucleus are your first structures that start to make choices about what you do. They can stop the amygdala dead in its tracks and say, well, not just yet. Next in line, getting more complex as we move up the food chain, is your hippocampi. Next in line, once again more complex again, is this green structure in this diagram. This is the back part of it, posterior cingulate gyrus. And here's the front part of it, anterior, just means front, cingulate gyrus. Higher level of functioning again, and perhaps the highest level of functioning in your brain, is the very front of your frontal cortex. Also includes, as you can see, the anterior cingulate gyrus. This is complex brain. This is where you carry conscience, morality, ethics, your personality, and it's where you make complex choices about social interaction. Classic example of what your frontal cortex gets up to is not taking the last chocolate. Now, not taking the last chocolate, your amygdala is saying, come on, grab it, take it, we want that. Your septates start to introduce some control in that, but your frontal cortex is making complex choices about that. If you don't take the last chocolate, and you do it in such a way that mummy notices, then on your way home in the car, hopefully she'll stop at the garage and get you a bottle of juice and some large chocolate bar, which is much better. So you've learnt behaviors that increase your reward by delaying gratification. Critical part of what we call emotional intelligence. Emotional intelligence is awareness of your own feelings and emotions, awareness of other people's feelings and emotions, and the ability to deal with those 2 things constructively. So let's now think about how it develops and matures from birth up until young adulthood. You can only be as old as your brain has reached neurobiologically. Very interesting statement, because it makes one, I hope, stop and think about who is this individual in front of me? What age have they emotionally reached in their brain? Because that's the only age they can be emotionally. If they haven't matured beyond that, well, they can't be more than that. The first structure that comes online after birth is your amygdalas. Remember, there's one in each hemisphere. And their job, as we've said, is basic survival. And they dominate behavior till 8 to 9 months of age to make sure that you get nurtured, that you get fed, that you get cleaned, all those things. And we now understand that that driving need of the amygdala is so you grow a normal brain in all its architecture and function. About 8 to 9 months of age, these structures, the septate nuclei, come online. And the septate's job is to start calming the amygdala's need for instant gratification down. They inhibit the amygdala. And by doing that, they allow you to start making choices. We know that about 8 or 9 months of age, human children usually become mobile if they're developing on the ordinary pathway. And we know that about 8 to 9 months of age, an ordinarily developing human child will start to make choices about who they get nurturing from. They start to recognize strangers and have fear of strangers. That relationship between septate and amygdala matures over the next couple of years. And then at about 2, 2.5, 3 years of age, this great big lump of frontal cortex with its great big mass of limbic brain comes online. And it also connects directly into the amygdala to inhibit it further. And it can make these complex, learnt choices about what's likely to end up with the biggest reward or escape the worst punishment. That relationship matures until you're about 9 years of age, and then what happens is adolescence. Now, adolescence is a pre-programmed neurobiological event, and to explain it to you, what I want to do is have a look at the basic neurochemistry of what's going on as adolescence strikes. So here we have the axes of our graph. Here is 8 to 9 years of age, approximately. Here is 18 to 20 years of age, also approximately. And what I want to talk about is two neurochemicals, the first of which is called serotonin. Now, all of you, I'm sure, have heard of serotonin in the context of adult depression, where serotonin levels are not sufficient, and we give drugs, the SSRIs, which are the serotonin reuptake inhibitors, to improve serotonin levels in the brain, which is a good way of trying to treat depression. Serotonin levels in the ordinarily developing brain gradually increase during childhood and adolescence before plateauing out in adulthood. I'm going to tell you in a second what that serotonin is doing, but first of all, I want us to think about another neurochemical called dopamine. Dopamine, I'm sure you've heard of in the context of the adult disease, very sad and tragic condition, Parkinson's disease. In Parkinson's disease, the brain stops making enough dopamine and the brain becomes increasingly less functional. Now, dopamine has multiple functions in the brain. It's critical for learning, it's critical for unlearning, it's critical for paying attention. But one of its core, very basic functions is to bring nerve cells up to a level of excitation. Dopamine levels during childhood gradually increase, but stay with a close ratio with serotonin. Why? Well, the answer is because if your brain is full of dopamine, is flooded with dopamine, it's hyperactive. It's sitting at a level of excitation which is not functional and useful. I'm sure all of you have at one point in your life experienced a sudden episode of stress. And you find, woo, I can't think clearly, I can't make decisions, I don't know what I'm doing. That's because stress floods your brain with dopamine, just like alcohol, just like drugs of addiction. All these things flood the brain with dopamine and make it less functional. So what you want is to be able to control the level of activation of your nerve cells so dopamine isn't able to push them up into this hyperexcitable state. And that's serotonin's job. Well, it's one of its many jobs, is it brings the activation of nerve cells down, makes it more difficult for them to fire. What happens with the onset of puberty, however, is that dopamine levels suddenly shoot up before gradually coming down again and settling back to the pre-adolescent ratio with serotonin. Now what this means is you've way too much dopamine in your brain and not enough serotonin. So your brain becomes hyperexcitable. And this is normal neurobiology. It is wired into you, it's genetically predetermined, and all adolescents do it. Why? Why? Well, because what nature wants is adolescents to take high-risk decisions with poor judgment, because then they achieve two critical goals. They break free of their dependence on their parents, and they learn how to interface with their peer group by trial and error so they can become successful as adults. This dopamine surge, we think, is the reason as well why adolescence is the commonest time to develop depression, bipolar disorder, schizophrenia, for autistic spectrum disorder to reveal itself with behavioral problems, Tourette's syndrome, and also addiction. All these things have their peak onset in adolescence, and the reason almost certainly is because of this dopamine surge, which produces this brain which takes high-risk decisions with poor judgment. Dopamine is our critical chemical in the brain to make your brain run normally. We know that people who are depressed, who have schizophrenia, who have bipolar disorder, who are addicted, their brains are not functioning normally and well. Dopamine is therefore the critical neurochemical in almost all of our brains functioning. As I've said to you, dopamine is critical for learning and unlearning. Dopamine is critical for paying attention. Dopamine, in the right concentrations at the right time, produces health in our brains. Not just emotional health, but all our brain activities depend on dopamine. In a therapeutic situation, therefore, where you're trying to support someone and help them feel capable and able of dealing with the situations and problems that they're trying to make sense of, dopamine is your critical friend. If you can produce dopamine in the right concentration, in the right places, you have maximized that person's ability to deal with whatever challenges or issues are facing them at that time. You are giving them the strength to move forward. What we now understand about dopamine and dopamine secretion is that 93% of dopamine secretion in the brain, 93%, is directly under the control of your limbic emotional brain. Now, the limbic emotional brain is controlling 93% of dopamine secretion. So you need to engage with that if you're going to support and help that person. This comes down to the oldest algorithm in the book, which all of you there who have any experience of dealing and supporting people with emotional illness or emotional problems knows. That if someone is in an environment where they feel understood, then that is good for their self-esteem. If those two things are true, then that's good for their self-confidence. And if those three things exist within that person, then they will feel emotionally engaged with the situation. And as I've already explained, if they feel emotionally engaged, it means their limbic emotional brain is fully connected with what's going on. And if that's the case, then you've optimized their dopamine secretion, you've maximized their ability to not only deal with the situation in the present, but also to learn or unlearn the things that they got wrong, the things that they got right, to give them strategies to move forward. And of course, what this comes down to is the oldest understanding of human behavior that there is. If somebody's in an environment or with someone where they feel genuine love, then their ability to deal with themselves and their lives is maximized. And this, of course, doesn't have to be some deep, profound Hollywood love. Just the sense of being understood, of your self-esteem and self-confidence being maximized, and of feeling safe, emotionally engaged in the environment you're in. Thank you.